Alright, this is the last example I'm doing for just plain finding critical points of a function. And I have a graph here. It's x to the 1/3 times x minus 4, and here's a nice graph. And what we're going to do first is see if we can find if there's any critical points. And it looks like there's a local min here. I don't really see a local max, but we'll see with our calculus. I'm going to set it all up where I have my f prime bar when we're done. And if you've been watching my videos, you know that we do that all the time. And the first thing is we have to find the first derivative and put it equal to 0 to find our critical points. Well, before we get started, we notice this is a product rule. So I'm going to do at my f and my g's. So I know that f is x to the 1/3. F prime is going to be 1/3 x to the negative 2/3. G is x minus 4, and g prime is easy. It is just plain old 1. So when we do f prime of x here, or y prime if you will, it's going to be f prime g, so I have 1/3 x to the negative 2/3 times g, plus fg prime, which is x to the 1/3. Now, you know that I always want you to factor before we put this equal to 0. And if you look at here, I have a term right here and a term right here. And I can see that I can take out an x to the negative 2/3 there. And that 1/3 is going to have to stay right where it is. So I have f prime of x. And I'm going to factor out an x to the negative 2/3. And when I do, I have a bracket here. I have 1/3. Well, you know what we're going to do? I changed my mind. Let's factor out the 1/3 x to the negative 2/3. Just make it look a little bit nicer. Now, you might be wondering why I'm doing that, because if I divide that out of here, all I have left in this first term is x minus 4. Well, then you look at here, I'm looking at this term right here. I want to factor this out of that. So you're essentially dividing those two. Well, if I have a 1 in front of there, 1 divided by 1/3 is a 3. So I have, okay, a plus 3. Now the x to the 1/3 divided by x to the negative 2/3, if you're dividing them, you're subtracting that. So 1/3 minus a negative 2/3 makes it a positive 1. Now I have f prime of x equals 1/3 x to the negative 2/3 times 4x minus 4. And I can actually factor out the 4 when I'm done, but this is good right where it is because it's in factored form. And we're going to put it equal to 0. Make a big T here. And when I do, 1/3 x to the negative 2/3 is going to equal 0. Multiply both by 3. So I have x to the negative 2/3 equals 0. Raise both sides to the negative 3/2. I have x is 0. So I have a point here at 0. And then I got 4x minus 4 equals 0. 4x equals 4. And x is going to equal 1. So there is the x values of perhaps 2 critical points. So I have a 0 and a 1 here. Okay? So if you look at 0 here, it looks like there's a vertical tangent line here at x equals 0. Doesn't mean that if it's not a max or a min, but I just want to show you that there is a vertical tangent line there. That's why that x equals 0 came up. But let's see if we can find a local min or a local max. It looks like it's at x equals 1. So let's set up here. I'm going to do local min. Could be, and that means minimum. And to see if we have a local max. It doesn't see if there is one, but we'll check it out. So the first thing I'm going to do is go to this factored form that I have right here. I always do this right here, and I'm going to go to the left of 0 so I can put a negative 1. Okay, so if I put a negative 1 here raised to this is negative times a negative, excuse me, a negative 1 raised to the negative 2/3 right here. This is going to be negative. If I use something between 0 and 1, we'll say like a 0.5 if you will. If I put it in here, this is still going to be negative. And then if I go greater than 1, like a 2, it's going to turn positive. Which this shows what our graph is doing. It's increasing here, it's decreasing here, and it's continuing to decrease here. So when I go to do the first derivative test, there's really nothing to do here because these are both negative, but this is negative and positive, so there is our local min. Okay, it's at 1 like we thought. Alright, so our local min is 1, and it actually, when you plug it back into the original, it comes out to be negative 3, but that also shows up here on our graph. And our local max, there is none, and that can happen. But this does show up that at 0, okay, at 0 there is a critical point at x equals 0. It's just that that's not a min or a max, so it's not going to be there. Okay? Well, that's number 5, and then the next video I'm going to talk about global max and min.